In our next hypothesis test, we're going to learn how to compare two population means two population proportions, by looking at two sample proportions. Now, the sampling distribution and everything is exactly the same as when comparing two sample means, but the sampling distribution will now be for proportions. Here is an example where the research question is there a difference between the proportion of men and the proportion of women that will like a new product? A research company went out and they sampled 200 of men and asked them if they liked the new product. 96 said they did. They went out and sampled 200 women and asked them if they liked the new product. 84 said they did. So the null hypothesis, we're going to start out by assuming the proportions are the same. The alternative is that the proportion of men and women are different. Using a level of significance of 0.05, we end up with a critical z-values very similar to what we've done before on two-tailed test. Critical z is negative 1.96 and 1.96. Calculating z, first thing we do is find the proportion of men. This was found to be 0.48. The proportion of women was found to be 0.42. And for this computation, we need to find the combined proportion, p bar sub c. In this case, you add up all the successes, divide by the size of the sample, and you get 0.45. Computing z, we use this formula, p bar 1 minus p bar 2. And then the standard error formula uses the p bar sub c times 1 minus p bar sub c all over n sub 1, p bar sub c times 1 minus p bar sub c all over n sub 2, 0.0497, and we calculate z to be 1.21. The calculated z value of 1.21 would cause us to not reject the null. And the researcher doing this would conclude that the proportion of men and the proportion of women that like this new product could be the same.